And just like that, the Kings are back in this game, Jerry.
Steal for Dominic McGuire.
Up ahead to Nick Young. Up high, and he scored! He was trying to throw it up for an alley-oop, but he got it anyway.
He was. Everybody on the Wizards smiling that time.
Stripped away by Minnesota the other way. Telfair! Oh, my! What an acrobatic play by Telfair as he tosses it up and through and gets fouled.
Midway through the fourth.
Hill to the basket. Gets out to Richardson. Richardson foul, and it goes! Jason Richardson with a circus shot and a chance for a three-point play. It's going in.
You don't ever want to be somebody else's highlight film.
No.
Well, we just became somebody's highlight film.
Dixon comes up with it. Ahead for McGee. And he is fouled. He whipped. He was getting ready for a windmill dunk, but it went in anyway. Brewer is watching Roy. And Okor got in there with some double team. Oh, and he still got it to go. How about that shot? You gotta love that guy's tenacity. Get the shot block and awareness of the shot clock winding down. All in one motion gets the score.
Iguodala thinking three.
Rolling in. Wow, what a play by Iguodala. The 360 in midair for his first bucket of the game. 360 and a left-hand finish. Lopez trying to set a screen. Carter. Oh, West went down. Carter stepped over, but the basket will count. And a foul. Carter just walked on the chest of Delonte West and kept going. Got a piece of it. Spaghetti has it stripped away again. Here's Jose under 8 remaining in the third quarter. 3-on-2. Parker goes up. Are you kidding me, Anthony Parker? Are you kidding me? Stop that. Well, gets it done with the D and then a spectacular finish.
Okay, guys. Let's see if this works now. Here we go. So, that was just a fun video on Focus. Alright. About basketball. And, you know, like all sports, you do have like some circles and some spheres in there. For example, the basketball itself is a sphere. Alright, which has some similar properties of a circle. There's a lot of angles going on as well, so I just thought something fun to kind of grab your attention. But here we go, 2.4. Other angle relationships and circles. Okay. Please let me remind you guys also that all of these theorems that we're talking about in class, I will give you a giant theorem sheet, and so you don't have to memorize them, just have to know how to use them. Okay. So theorem 1012: if a tangent and a chord intersect with a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. It's basically the same thing as our inscribed angles we talked about in our previous section. Okay, this angle is double this angle, or this angle is half of this angle. Now there's two ways to do this. You could say 4x, the inside, equals 1/2 the outside. But I'm going to do something else, okay? Or, instead of doing fractions, because I know how much we all love fractions, you can times the inside by 2 instead of equal to the outside. Okay? I'm going to encourage you guys to do this one because it will avoid fractions and it just makes our lives way easier. Alright? So if I do 2 times 4x, I get 8x equals 12x minus 100. I can subtract 12x over. Negative 4x equals negative 100. Divide x equals 25. Now, I'm not quite done because it says find the measure of angle KLM, which is inside here. So it says KLM is 4x. I'm going to put a 25 in there, which which gives me 100 degrees. All right? So, very, very good. Same idea for number 2. It's the exact same thing. QR is tangent to the circle. Find the measure of angle QRS. So here, my inside angle, I'm going to double it, times it by 2. So 2 times 5x minus 10 equals 8x plus 32. So I can distribute the 2 in. 10x minus 20 equals 8x plus 32. Pardon me. Subtract 8x over. 2x minus 20 equals 32. Add 20 over. 2x equals 52. Divide x equals 26. Now it's telling me QRS, which is right here, 5x minus 10. So 5 times 26 minus 10, 130, okay? So 130 right there, minus 10 is 120 degrees. Please feel free to grab a calculator and plug that in if need be, okay? Alright, theorem 1013. If two chords intersect in the interior of a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, real simple terms. A lot of math mumbo jumbo can be a little confusing. If I want to find angle 1, I add up the arcs on the outside and divide it by 2. That's all I'm doing. Okay, like I just figure out their sum. So down here, if I want to find x, angle x, the measure of angle x, is going to equal to 1/2 the 2 outside across from it add together divided by 2. So we have 1/2, let's see here, 6, 286, add them together, half of that, 143 degrees. I'm just finding the average of my 2 outside. Alright? Now, for this one, okay, it's a little different. Can you please note that x is not directly across from 86 and 106? So what I'm going to do here is I'm going to put another letter in here. I'm going to call this y. Just a different letter. And now I'm going to solve for y. Because it's 1/2 my 2 outsides, 86 plus 106. Why am I doing this again? Look where x is at right here. See how straight across, straight across. See how here, straight across is not the numbers it gave me. So measure of angle y, 192. 96 degrees. Okay, so that means this right here is 96 degrees. Well, it forms a straight line. What's a straight line equal? Hopefully we're all okay with 180. So if I do 180 minus 96, I get my angle of x, which is 84 degrees. Okay, it's going to be a common theme for a lot of geometry with straight lines being 180. Please just keep that in the back of your mind, and it'll really help you guys out. Okay, on to the back. Our final theorem for today is actually one theorem with 3 parts. So let's take a look at each example. Theorem 1014. If a tangent and a secant, 2 tangents or 2 secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measure of the intercepted arc. Alright, basically, measure of angle 1, the outside angle formed, is equal to 1/2 of big arc minus little arc. Now, I know there's 3 pictures here, but they're all exactly the same thing. Small angle is equal to 1/2 big arc minus little arc. Outside angle is equal to 1/2 big arc minus little arc. Okay, I'm giving you all of these. Okay, so you will have this on a theorem sheet. Again, do not panic about that. So let's take a look at some examples. Okay, number 4. I want to find x, which is my outside angle. 1/2 big arc minus little arc, but you have to make sure you put that in parentheses. Okay, so order of operations, do what's inside the parentheses first. 44, 1/2 of 44, 22 degrees. Okay, it's that simple. Now, over here, please note that I'm not given the outside angle, I'm given the outside arc. So when I plug this in, it's a little different. This goes where the X did over here. So I'm going to start off with 58 degrees equals 1/2 big arc minus little arc, X minus 64. Now again, do we like fractions? Some of us might, but for the most part no. Multiply both sides by 2 to get rid of this 1/2. 58 times 2 is 116 equals X minus 64. Now it's way easier, because all I got to do is add 64 over. X equals 180 degrees. Okay, but again, note the difference. Here X is on the outside corner, here X was on the outside arc. We're back to the outside corner here, but see how they're only giving us 110? How in the world could I ever find this? Well, a whole circle is 360, so 360 minus 110 is 250 degrees. So I'm back to angle X equals 1/2, outside arc is 250, minus inside arc is 110. Okay. Angle X equals 1/2, 140 degrees. Now I do half. Angle X equals 70 degrees. Alright, and our very last one, please note that X is not the outside arc, but now it's the little arc. So again, outside angle, 72, equals 1/2 big arc minus little arc, 210 minus X. Multiply both sides by 2, 144 equals, that cancels out, 210 minus X. If I subtract 210 over, okay, let's see here, 66, negative 66 degrees. Divide both sides by -1. X equals 66 degrees. Just a quick side note, again, to check yourself. If you're solving these and for some reason your answer ends up being negative, double back and check your work. You should never get a negative answer in this class. It just means you might have forgot a sign, maybe you dropped the negative sign of the X, whatever the case may be. Just be careful and you'll end up just perfectly fine, okay? So that concludes this little section, right? And most importantly, good luck. We're all counting on you.